Hello, everyone. Today we will explore the charm of Mechatronics Concept Designer, MCD, through a case model. Before we begin, I'd like you to consider why motion simulation has become so crucial in modern engineering design. How does it help us optimize designs and enhance efficiency? Next, we will cover the following topics. Learning objectives for this lesson include 1. Learn to create sketches and set them as movement paths. 2. Master how to set model components as rigid bodies. 3. Learn to set up joints and actuators. Now, let's delve into the specific operation process. We will now begin the demonstration of the specific operational steps. Open the case model. Before setting up MCD, create a sketch first. Click on Sketch under Home. Select on Path, choose an edge. And click on Specify Vector. Create the movement path on the side of the drag chain. Set the diameter to 57. Adjust the sketch to overlap with the center path of the drag chain. And finalize the sketch. Next, navigate to the application module. In the design menu, click on the downward triangle under More and enter the Mechatronics Concept Designer module. Now, let's start setting up MCD. First, we need to set the mechatronic objects. Set the movable components as rigid bodies by clicking on the Mechanical menu, then Rigid Body. Set each part of the drag chain as a rigid body. For mask properties, select Automatic. Having set the 18 sections of the drag chain as rigid bodies, proceed to set up the axis's moving arm. Ensure all model components moving together are set as the same rigid body, checking for any omissions by rotating the model, and click Apply. Additionally, set the movement path we just configured to rigid body. Click OK. The rigid body setup is now complete. Next, we set the joints. Click on the mechanical menu, select Basic Joint, and then Sliding Joint. Do not select the Z-axis body. So when setting joints, only select attachment. Set joints for the Z-axis with the vector orientation pointing upwards, and click Apply. Now, set the drag chain's movement path as a sliding joint with the same upward vector orientation. Leaving the base unselected, and click OK. Next, we will configure the point on curve joint. Click on the mechanical menu. Select Basic Joint, and choose Point on Curve Joint. Select the first section of the drag chain as the attachment, and the curve we created earlier. Specify the 0 position point with the orientation set to downwards, and rename it. Now, settings for the second section. Downward orientation. This completes the joint setup. Next, we will set the actuators. Click on the electrical menu, then the downward triangle under position control, and select speed control. Choose the first application we set up, the second sliding arms movement execution, and one actuator for the point on curve joint. Then click OK. The basic mechatronic objects, joints, and actuators are now set up. Next, let's configure the runtime parameters. Click on Runtime Expression. Select the Float tab, and drag it out. Two settings need to be done. One is to set the relationship between the movement path and the axis's movement, then click Apply. The other is to set the relationship between the point on curve joint and the axis's joint, then click OK. Close it to return to the navigator. After setup, click on the mechanical menu, then the downward triangle under More, and choose Point on Curve Kinematics Chain. The master object selected is the first master key of the drag chain. with the rest being follower keys. Starting from the second one, click on it, hold down the Shift key to select through to the last one, and click OK. To enable the simulation to run, we need to utilize the Sequence Editor. Click it, right-click on the Float tab, and move it below. First, to make the Z-axis move upwards, select the object Z-axis, setting its speed to 50 for positive movement. Followed by -50 for negative movement. And finally returning to 0, then click OK. Long press the left mouse button to connect them. Now let's play to observe the movement of the chain. Close this for clarity. To make it look better, hide the sketch. This concludes the setup process for the drive chain. This case ends here. Today, we learned how to set the movement of the drive chain in the MCD module. Through this case study, we not only mastered a series of operations such as creating sketches, setting rigid bodies, joints, actuators, and performing motion simulations, but more importantly, we understood the significant role of engineering simulation in modern design. I hope you can apply what we have learned to your practical work and contribute to the development of engineering. Finally, please complete the following exercises and practice more in your spare time. This lesson ends here. See you next time.